So let's roll right into it. Item B this morning is overview of onboard ballast water treatment systems. And this morning we have Robert Hayes, Manager of Marine Engineering, and Eric Harrier, Director of Engineering and Compliance for Polar Tankers. Welcome, gentlemen.
Yes, good morning. Can you hear us okay?
Sure can.
Good morning.
Yes, well, good morning. Yes, and Donna, thanks a lot for reaching out to us. Again, as you mentioned, my name is Bob Hayes. I'm the Manager of Marine Engineering for Polar Tankers. Chris Valera, our President of Polar Tankers, is not able to be here this morning, but also sends his regards and thanks for giving us this opportunity to share with you some information on the ballast water treatment system that we've selected and are installing on all the polar vessels. Our journey to where we are today started 7, 8, 9 years ago when we first started looking at ballast water treatment systems. The system that we chose after all of our analysis is the BALPURE slipstream electrochlorination system. It's built by Denora Water Technologies, and one that already has all needed IMO and US Coast Guard approvals. Our plan today is just to give you a little bit of a background on how our system operates and give you some insight on the scope of the project and how we approach them, including some information and pictures from the installation that we did on the Polar Adventure. I've asked Eric Harrier, our Director of Engineering Compliance, to do the presenting today. So thank you again for the opportunity. And with that, I'll turn things over to Eric.
All right, thanks, Bob. Thanks for the introduction, and thank you, everyone else, for inviting us. Let me share my screen. As Bob mentioned, our plan is to give you an introduction and an overview of the ballast water system that we're installing on our polar vessels. I wanted to give you a little bit of an understanding of the technology of the treatment system we chose for the polar ships, and then maybe talk a little bit about the design development, and then finish with the installation on some of our ships. So I thought, I'm sure most of you are aware, but I thought I'd start from the beginning with what ballast water is. So ballast water is required for stability of the vessels when they're not carrying cargo. So most of the ships today have some sort of a ballast water system to load salt water, it's seawater, into the ballast tanks to offset the load that's not there when you're not carrying cargo. So when the tanker's at their discharge port, discharging cargo, they're getting light in the water. So that at that time, we're going to be loading ballast into the vessel. As you can see on the slide, when that happens, there's the opportunity that you're going to be loading invasive species, any kind of critters in the water, with the ballast water as well. Now, on the other end of the voyage, when we're de-ballasting at the cargo port, we're going to be pumping that water off. And there's also the potential for those organisms to be pumped off with the ballast water into the surrounding waters. Which brings us to the whole reason that we are installing these systems is to manage the spread of invasive species. So the IMO, starting back in 2004, had a convention to try to stop or limit the spread of invasive species across the world. With the convention going into force in 2017. The short of it is that under the convention, all ships traveling internationally are required to have ballast water management systems on board. And for most ships, that means, and polar vessels are included, for most ships, this involves installing a ballast water treatment system. And the ballast water treatment system is the kind of, by definition, that's what it's designed to treat the water to prevent the spread of aquatic invasive species via the ballast water between ports. And as Bob mentioned before, we chose the BALPURE system by Denora Water Technologies. It's an electrolytic disinfection system. So on the ballasting side, and that is when we're loading water onto the vessel, the ballasting, the treatment of that ballast water, it's a two-step process. The first one and the most critical step really is the filtration. Now, so this is a representative photo, but it's actually a pretty good representation of the filters installed on our vessels. These filters filter 100% of the ballast water prior to entering the ship. Prior to entering the ballast water tanks. And it's filtered to a level of 40 micron. And just to put that in perspective for you, human hair is approximately 75 micron. So it's moving a lot of material right off the bat. And also as an aside for us, it minimizes the silt in the tanks, which is also part of the management, the ballast water management convention regulations as well. The second step, but still prior to getting into the tanks, is to chlorinate the ballast water. And this system does it through what's called, sounds very technical, but slipstream electrochlorination. Yeah, a little bit of a tongue twister there. Which is basically, and we'll go into a little bit more here in the next couple of slides, but basically it passes an electric charge through the water and breaks it into its constituent components, which makes a solution of salt water and sodium hypochlorite, chlorine, to use as our disinfectant. So here, this is just an overview of our system to give you a better understanding. So we'll start down on the bottom. So this would be the main ballast water intake. So this is 99% of the water that is entering the vessel for loading ballast, and it'll come through come onto the vessel through a pump and through our filter. We monitor the flow, and that's kind of important here. But we monitor the flow as it comes on board. And I'll stop there for a second and then take you up here to the slipstream. And this is was 1% of the ballast flow. It's processed through these units here. This is really just a pump and a heater if we were to need it. But this is the important piece of equipment here. This is the electrolyzer. And as I mentioned before, that's where we pass an electric current through the salt water to create that sodium hypochlorite. From there, that solution now of salt water and hypochlorite is injected into the ballast flow prior to going into the tanks. And this little guy here in the blue, it's called an ORP. That's a oxidation reduction probe. And what that does is it just allows us to measure the concentration that we're dosing the system. In red here, just to point out that this is all happens automatically. You know, the system, when you go to load, we program what we want, what our anticipated chlorine levels are going to be, and the system will automatically dose the appropriate amount based on our input and based on flow. So it'll adjust if we slow down using 1 pump, 2 pumps, whatever. It'll automatically adjust to manage that. And then on to the ballast water tanks. And on the top here, this little yellow line, as a byproduct of that process, some hydrogen is produced. So this system separates the hydrogen from the water and dilutes it with a fan and sends it to the atmosphere. Now, these next couple slides, there are a couple of videos that to hopefully better explain what I just went through with you. Let's see if it moves up. And if everything goes well, the volume will also work.
Yeah, we hear it now, Eric.
Okay. What we're showing here is I just wanted to show you, this is one of our filters, and they're kind of different. Let me pause it for just a second. Sorry. Our filters are a little bit different in that they're self-cleaning, and they can clean dynamically, meaning that they can clean while they're filtering the ballast water. and that's really, I meant to tell you that before I started, but that's really the purpose here. But they have a really neat animation to kind of give you an idea of what they're doing on the inside. So as you can see here, the sediment's starting to build up on the inside of the filter. And now those little arms, those are like vacuums. They're going through and they're cleaning, actively cleaning the filter while we're still processing ballast. All right. And this next slide, this is just an overview of the of loading ballast. So it's going to take you through that process. I just kind of talked you through of loading the ballast, the electrolyzer, but it gives you an X-ray view of the electrolyzer well, maybe better demonstrates that for you.
Active treatment occurs only during the uptake on the ballasting operation. The main ballast flow passes through a strainer or filter to remove larger organisms and particles. At the same time, a slipstream of 0.5 to 1% of the total ballast flow is fed to the electrolyzer. Direct current power is used to pass electric current between the terminal plates of the electrolyzers and through the salt water to drive the electrolytic reactions to produce the sodium hypochlorite solution. This solution is highly effective against bacteria and other microorganisms with a contact time of less than a minute. Hydrogen gas, a byproduct of the electrolytic process, is passed through a cyclone-type degas separator to instantaneously separate the entrained hydrogen gas from the liquid flow, then diluted with air and safely vented to the atmosphere. The 1% slipstream, which is now a mixture of seawater and hypochlorite, is then mixed into the main ballast flow and used to disinfect the entire volume of ballast water. The total ballast water flow is then transferred to the ballast tanks. A residual disinfectant remains in the ship's ballast tanks during voyage, preventing any possible regrowth of organisms.
So, yeah, let me get to the next slide there. So now that takes care of ballasting, bringing the water on the ship. So when we get ready to discharge the ballast, there's a process. It's not as involved as the loading of the ballast, but there's a process for getting it off. And so what we're doing, what you're seeing here is from this area here, the water is going to come from the ballast tanks. And generally, so when you load ballast, there's a certain amount of that hypochlorite in the water at the beginning, and it degradates over time. But there's going to be a little residual left in that water. And so as it comes out of the tanks, we have another ORP probe here to measure exactly how much residual is there. And based on that, this skid here, this is the purpose of this unit is to dose a small amount of sodium bisulfite into the system, and that's indicated here. So it's going to, based on how much chlorine's in the system, it's going to dose the sodium bisulfite prior to the pumps or prior to going overboard. And the last thing in the system, just before it goes overboard, is another oxidation or an ORP probe. And the purpose here is this is a verification that we've dosed it properly and removed all the residual chlorine. And just as before, it's an automatic control loop. So the system is monitoring that and adjusting as necessary to make sure that it's doing what we intended. And this next slide is going to be a video similar to the last one, just kind of showing you a little bit of that process.
De-ballasting is simple, fast, and requires no active treatment. The power requirement for this process is negligible, measuring less than 2 kilowatts. Ballast water is pumped out of the vessel, but prior to overboard discharge. A separate and small stream of sodium bisulfate is automatically added to the inlet of the ballast pump. This neutralizes the residual hypochlorite disinfectant, so the seawater discharged is safe for the marine environment.
All right, Well, I hope that kind of gives you an idea for the technology and how the system works. These next few slides, I wanted to try to convey to you what we went through to get to this point, the development process, the design, and then finally the installation. This slide here, it's hard to show you the scope of a project, especially one of this size, but I thought that this slide might be helpful. And what you're looking at here is this is just a schematic of our ballast water system. And well, I should say this was a schematic of our ballast water system. All this stuff in black was the original piping, the original system. Everything that you're looking at that's red or blue, that's all the additional items that we installed for the ballast water treatment system. So you can see by comparison, just if you look at the two portions of the systems, the ballast water treatment system, it's a lot of stuff. As Bob mentioned, the planning process started about 7 or 8 years ago. So this is something that's been going on for quite some time. In Polar, we chose Denora Water Technologies, as we mentioned before. Throughout that process, we really worked close with Denora throughout the development phase. We wanted, well, of course, this is a retrofitted system, so it needed to be modular in design. So it needed to be able to fit into the different areas of the ship without having to create a whole new structure. And as you may know, our ships are designed with a high level of redundancy. And we wanted to continue that redundancy on into the ballast water treatment system. So with that in mind, just like we have, say, two engine rooms, 2 engines, 2 means of propulsion. We have 2 ballast pumps. We also have separate ballast water treatment systems, all one system, but components. So that if one should fail, we can continue with the other, or you could actually use both at the same time if you want to do 2. But it was important to us to incorporate that level of redundancy into our systems. Also, while we were working with Denora, we had the opportunity to, it wasn't just an off-the-shelf item. This is a very bespoke system that we had, as I mentioned, a lot of input on how it was designed. We wanted it to be a standalone system, but obviously it has to integrate into our systems. One of the things that we wanted to take into account was the human factor on the vessels. We wanted the input from the operators on operation of the system, and looking forward to maintenance of the stuff down the road. So we had input from the operators, the ship staff, and we're able to go back and incorporate that in the design. So this next slide, this is a kind of a neat one. This is the picture of all of the equipment at the factory at Denora. This is actually taken last week. So as part of the process, one of the things we wanted to do was, as our installations are done in Singapore, we want to take extraordinary steps to make sure that everything works. Everything worked the way it should before we got it there. We didn't want to have to figure it out after the fact. So we, as part of the design, we incorporated what they call factory acceptance testing, and I'll refer to it as FAT. But so this is a photo of an FAT. This is the final one that we just finished up last week in Sugar Land, Texas. And what you're looking at here is, so this is on the factory floor, but all of this area here in the center of the floor, this is all of the equipment for one ship's system. And what we're doing here is that it's all set up. It's got water going through it. It's got power. It's able to operate, and we're able to run it through its paces and test all the controls, all the shutdowns, and make sure everything works. So this was a big step in making sure that we had a successful installation and actually got the product that we had intended when we started the process. And as a note, the one thing that isn't in the photo here, and those are the filters, those big blue units that you saw previously. It's not possible to like move ballast in the way that we do on a ship. So those are tested at their facilities in Europe prior to being shipped to the U.S. And lastly, so we wanted to take our system, have it inspected to the highest standards possible, and that is, it's called the BWT plus notation, and that's a notation given to us by ABS, the American Bureau of Shipping, that basically means that the ABS is involved with the building and commissioning the system from front to back. So through they're there to inspect the equipment as it's being built. They're there at the factory acceptance test, and of course they're there at the end when we run the system and finally install it. And lastly, since we are U.S. flag Jones Act tankers, our ships must and do meet all the IMO and U.S. Coast Guard standards. So this next slide, this is actually photos from the first FAT that was back in December of 2018, also at the Sugar Land facility there. And as you can see in the photos, what they're doing is just putting it through its paces. We have, I just went through it last week. That last photo, that was actually me there. 730, I think it was, individual tests we have to go through to make sure, every alarm, every trip, every shutdown has to be tested. And so that's what the guys are doing here. One of the benefits of doing that is that, since especially on the first install, that allowed us to, if there was anything that we noticed that wasn't quite what we were thinking or didn't work the way that we intended, it allowed us to make modifications right at the site. The programmers are right there, the engineers are there, and they can make all the changes necessary before it ever leaves the factory and gets shipped to sent to the ship. And the last part of the testing is that they can actually run the system and produce hypochlorite. This tank here, this is one at the beginning of the process. It's filled to the top, and they add salt to it, so it's simulating salt water, seawater, and they actually run the system and produce hypochlorite. And they have a little chemistry lab off to the side, and they can measure the content and prove that the system is doing what we intended it to do. And this slide, so now we've finished with the FAT, and I wanted to show you this. This is all of the equipment being boxed up in preparation to being sent to Singapore. And I just wanted to show that to you to see, get an idea of how much equipment we're talking about. One thing not in those photos are the filters, but it's quite a bit of stuff. And now we move on to installation. And as I mentioned before, it's really hard in a few slides to give you an idea of the scope of the work. But I've tried to pick a few just to give you a sense of what was involved with installing the system. Now, these photos are were taken in 2019 on the Adventure when we installed her system. The photo on the left is, so we have a forward system for the main ballast, and we have a aft system for the after ballast system. This is one of the filters being lowered into the engine room for the aft ballast system. It's about as big a piece of equipment as you can get into the engine room without cutting a hole in the deck. And the photo on the right, that's actually one of those filters installed. It's one and its partner. Remember, I talked about redundancy before. This is an example of that. In this system, we have a filter for the port side and then another filter for the starboard side. But all this is installed after we did all the testing there in Singapore. This is for the aft system. And this, fitting that other filter into the ship on the aft side was a challenge, but the forward filters are even more so. And I thought this slide kind of puts it in perspective for you. And what you're looking at is, of course, we'll start over here. This is the forward filter. It's so large. This goes in the pump room. It's so large that there's no space. There's no way that we could actually load it into the vessel. So that meant we had to cut a hole, actually two, because there's a port and a starboard. Had to cut 2 holes in the side of the vessel to allow us to load them in. So that's what you're seeing here. This is a view of the side of the ship, of the hole from the dry dock. So as you can imagine, this is not something that you can just do to a ship. You can't just punch a hole in the side and patch it back on. It has to be all done, and there's a lot of planning and preparation involved. As you can see in the bottom of this photo, the ship's in the dry dock. It's not something that we can do while it's afloat. And the other part, the other takeaway from this is to realize that this area is normally below water. When the ship is in trade, I'll go to this slide here. The water is generally like a full load would be up at this level, so it's well above the area where that hole is. So it's something it's a serious and an involved task. And then the last thing I wanted to show, just to put it in perspective on the side, is there are 2 guys there flagging and controlling the loading of that filter. So just to give you a little sense of scale there. Now on this slide, I thought it was just interesting to give you an idea of what was involved. And so we've broken it down into well, this top section is weight. So this is all the equipment, all of the steel, piping, everything added up. Added weight of 135 tons to the vessels to install the ballast water treatment system. There's 9,800 feet of piping and tubing. That's quite a bit. And then lastly, this is kind of astonishing, but 61,000 feet of installed cable, which equates to 11.6 miles. So I hope that kind of shows you what helps you get an understanding of the scope of the project. All right, and lastly, I just want to thank you again for the opportunity to talk to you today and share this with you, and open it up for questions.
Great presentation. Thank you, Eric.
You're welcome.
Any questions from the board? And I see quite a few hands up. So we'll start with Steve Lewis.
Yes, Eric, thank you very much. Steve Lewis here. I'm the chairman of our Port Operations and Vessel Traffic System Committee. And my relationship with Polar actually predates Polar back to the Arco Marine days, but I want to thank you guys specifically on 2 things. One is your sharing this information with us. One of the things your organization has always been is open and transparent. And then the other is your technical competence. You guys were doing a good job then, and it looks like you're doing a good job now. I got a specific question about this system. It looked like all that piping was stainless, pretty expensive stuff. Can you share with us a rough ballpark what it's costing you guys to make this upgrade per vessel?
Yeah, I can handle that one. That's in the ballpark of $6 to $7 million, I guess. When you look at all the equipment that we have to purchase, and all the testing that has to take place, and then getting folks, all of our technicians and people to Singapore, that's where we're doing the work. But all in, yeah, between $6 and $7 million per ship.
Mm-hmm. Okay, that's actually kind of lower than I would have thought. The other thing is just a request I'm going to repeat from yesterday. You'd mentioned that this was the result of a 7 or 8 year process with current changes towards carbonization. You guys are launching on another process, I'm sure. And my request is, as you move forward with your designs, you're thinking about new builds, you're thinking about repowering, you keep us in the loop of what you're thinking of doing, and that way we can be more informed and possibly have some better thoughts and suggestions as we move along. So once again, thank you very much.
Yeah, thank you, Steve. And yeah, you're right. We are already well engaged in some of those discussions about if we have the opportunity to do new builds down the road, how we'll approach those, what that will look like. And obviously there's a lot of discussions too, just again, on some modifications that may have to take place on ships on the West Coast here in the next few years. I think, as you know, you have the appreciation there for certainly easier to do all this on new builds. You know, a lot of the information that Eric shared with you there, to do some of this, you know, with a ship that's already built can be challenging at times. And yeah, this ballast water treatment system was a challenge, just trying to find the space and find access to get everything into the ship. But thank you for that. And I appreciate, you know, you mentioning, I too am an old ARCO guy. I sailed back in the early 80s for about 10 years with ARCO many years ago, and had the opportunity to come back to ConocoPhillips polar tankers here about 16 years ago. So thanks for the comments there, Steve. We appreciate that.
Yeah, thank you, gentlemen.
Thanks, Steve. Mako Haggerty.
Yeah, thanks for the presentation. That was fascinating. My question is, how much involved, or has the Coast Guard been involved in this process? Because just like you mentioned in your answer to Steve, the West Coast, it looks like they're, you know, starting to develop some requirements about ballast water, and you know, was the Coast Guard included in on this? Are they, you know, were they part of the design process?
Excellent question. Yes, and I can assure you that they were, you know, and part of our decision process, you know, when we first started looking at this many years ago, you know, we probably looked at 30 to 35 different systems, and part of that decision and where we ended up with our final decision was that very question there, you know, who's been around long enough, has the technology, has the knowledge to be able to deliver a IMO and U.S. Coast Guard approved system. And because we operate on the West Coast, the U.S. Coast Guard system was very key to us. So yes, they've been involved with us all along, and part of our contract, just sharing this, was, you know, guarantee that the systems that were put on our ships met all of U.S. Coast Guard requirements. So the systems that we're putting on today already have all the required U.S. Coast Guard documentation for them.
Great. Danielle Verna.
Yeah, good morning. Thank you, Eric and Bob. That was a pretty interesting presentation. I have kind of a two-part question here. First off, I was wondering if you could remind us which of the polar tankers in the TAPS fleet have these systems installed on them. And then the second part of that is, are they operational? Because we've seen in other parts of industry that installation isn't necessarily equivalent with operation as crews get up to speed and, you know, and other things come into play. So I was just curious if you could enlighten us on that.
Danielle, great question, and certainly agree with you. Again, I think, you know, as we approach everything there, you know, we want to make sure when we put something on the ship, it's going to operate, and we try to do our homework up front. And very proud to answer your question. We have it currently installed on one ship, the Polar Adventure, today. We have a ship that's en route to Singapore right now, the Polar Enterprise. She's scheduled to have it installed on her later this year. And all of our other ships subsequently have to have it in the next required, or their next dry dock schedules. All in by 2023, all of our ships will have these installed. And as Eric showed you, just due to the scope of work involved here, you know, this isn't something we could just pull aside for a few days and put on. They have to be done in our shipyards and dry dock periods. So And you know, the rules today are all, you know, per Coast Guard's acceptance and approvals. We've got to schedule an agreement with them today about the time that we need to put these on our vessels. But the system on the Adventure has been very reliable. We've had some, you know, we did a lot of homework in advance before we even put it on the Adventure. There are some ports down in California where there's a lot of silt in the water, and you know, filters and all of that. We're thinking forward could cause problems. And actually, we put a test filter on one of our ships probably 7-8 years ago, just to understand what that would mean, and you know, the challenges there. So we've had a few challenges there. We've worked through them, I guess, with the systems that we have, and you know, are very confident in our systems. So thank you for the questions.
Thank you.
Austin Love.
Thank you, Robert. Fantastic presentation, really enlightening and really clear and easy to understand. So I appreciate that. And what a remodel that you all had to do there and have to do. My question is just about corrosion control. Just as I was looking at the pictures and everything like that, it looks like corrosion control on the piping and tanks is all, it looks like it's being dealt with through material selection. So I don't know if you could talk more about that. Is it just stainless steel piping, a mix of HDPE, things like that? How are you controlling for corrosion in the system?
Yeah, and I'll ask Eric to jump in on this one as well too. But yeah, I think a lot of the pipe that you saw there is copper nickel. You know, some of the challenges, you know, again, just some of the forethought there, just because of where we have to install this stuff on a ship that's already been built. There are challenges with, you know, you might have done it a little differently if it's a new build and you have an opportunity to build a ballast water treatment room or whatever. But with some of these requirements that come out and they say, you know, they don't take those things into consideration, you just have to make it happen. We give a lot of thought, like, where is this going to go? And what do we have to do to prevent a leak in a space that we don't want there to be a leak? So we've used an awful lot of copper nickel pipe. There's a premium for that, obviously. But
hi, Josh, this is Pat.
It's the right thing to do.
Question for you.
I can jump in a little bit there too, Bob. So to further on that, all the piping in the aft system is copper nickel, and part of that is it has to be compatible with the adjacent piping that we're using. So and that's what the rest of the systems are back there is copper nickel. Well, for the most part, to a point. The piping for the hypochlorite, that's a PE line, polyethylene lined steel pipe. So that's, as you can imagine, that's a process. We have to fit it into place, build it, you know, so you have to get the size of it. Then you have to send it off to a factory to get that lining done and then brought back in and installed. So there's a bit with that. The tanks and the rest of the piping, it's all coated steel. The tanks are coated and the forward piping is all coated. So at that point, the amount of you know, chlorine in the water is so little. It's no more of a concern than it would be just in a saltwater system. And as you mentioned, also stainless steel for the bisulfite. We use a lot of stainless steel there too.
Great. Yeah, thank you for that.
Jim Herbert.
Thank you, gentlemen. Very nice presentation. Right now, I correct that the tanker traveling, say, California to Valdez, changes their ballast water fairly continuously en route to kind of meet these kind of requirements to minimize invasive species. Is that correct?
You broke up a little bit there, but do you want to take this one, Bob, or would you want?
No, I was going to ask for the same thing. I'm sorry, Jim. We didn't hear the whole thing. You broke up a little bit there. It sounded like you were talking about the ballasting coming in, but we didn't hear the whole question.
Let me try again. Otherwise, I'll pass to the next person. Is this any better?
Yes, that's better.
A tanker traveling from California to Valdez right now continuously exchanges ballast water to minimize the introduction of invasive species. Is that correct?
Yeah, I wouldn't use the term continuously, but yeah, they do. So they load when they're down there, and when they get out to sea in open water under certain conditions, there's requirements about when they can do it and how far away from land, depth of the water, all that sort of thing. But then yes, they go through a ballast exchange process. So they pump it off and pump it back on en route, so that by the time you get there, that there's no more of the ballast that was from the discharge port.
Will that same process be used even if this fancy system is aboard? Seems like that's cheaper and less wear and tear on equipment. Will you still have that option in the future? Is that part of the IMO procedure? Thank you.
Oh, Bob, you want me to, or
yeah, go ahead, Eric, or
sure. Yeah, I didn't get too much into the legislation part, into that level, and I don't presume to be an expert on it. But there were two stages to that process. There's a first stage that were we allowed to do the ballast exchange, but the second stage, and that's a tier 1, and then the second stage does require, it has tighter constraints on that. And there's really, at that point, no way you wouldn't be able to meet those requirements by just doing a ballast exchange. It requires a ballast water treatment system of some sort to mitigate and manage all of that. So to kind of answer your question, it's not a possibility to continue to do, if that was your question, continue to do the ballast exchange.
Yes, thank you very much. Thank you.
Yeah. Just to build on that, we have a lot of discussions with, the question came up about Coast Guard. They really kind of mandate this and the requirements. And by rule, by law, each ship has a scheduled time when this installation has to occur. And if you're not able to make that window, you have to have a Coast Guard concurrence and an extension, a written extension in place, explaining why and convincing them that, yes, there isn't a way to do that. And we've run into that a few times just with COVID here, honestly, in our last projects. Just the logistics of getting stuff over, there's been huge delays in that, getting technicians that are needed on site into a country is a real challenge. Even today, just to get a technician on board our ship, they have to quarantine for 2 to 3 weeks, depending on where we are in the schedule there with Singapore, before they can even set foot on board our ship. So there have been some challenges, but yes, Coast Guard's very involved in all this. And we have firm dates by Coast Guard rule that these have to be installed. And honestly, if we don't meet those needs, we can't sail our ship unless we get an extension from U.S. Coast Guard.
Great, thank you for that. Robert Beadle.
I've got about 40 questions. That was an awesome presentation, and it kind of, I was an old crabber. I see your plumbing and stuff. So right now, your pumps, I was looking at the data on it, and they're like 12,000 gallons per minute. So yeah. I mean, is that a big electric motor on them?
Yes.
Yes.
Gosh, so soft starts and all that.
Yes.
Yeah.
Wow, I'd love to see it. So before I get too off in La La Land here, so was there additional power supplies and additional crew to observe and run this?
That's a very good question, and one of our factors when we went into this, because obviously our ballast system, the pumps that we have, even going forward, are the same pumps we had on before. Today they just have to go through. They have to be integrated into the ballast water treatment system. So, I mean, there are a lot of other systems out there that do have a lot of power consumptions considerations. For this particular system, it was one of our deciding factors there. The consumption is certainly a lot less than some of the UV technologies and infrared technology, those kind of things. So yeah, we have not had to increase our power consumption on these ships to accommodate these installations. We had power to accommodate that.
And is there additional crew to monitor it? I mean, it's still another piece of equipment, or is it just another thing for the engineer to?
There's a lot of discussions going on that right now. And, you know, as Eric had mentioned, there are ships, a lot of redundancy, you know, our commitment to the environment. We wanted that to be the same for these ballast water treatment systems. So, you know, if something was to go down, we have 2 and sometimes 3 different opportunities to be able to keep the system going. So there is a lot of equipment on board. We do have a very good maintenance program for that. But, you know, the other piece, as Eric touched on, when we installed this, we tried to incorporate as much of input as we could. And right now, our crew manages things on the ship, but it's something we're keeping an eye on as the equipment ages a little bit, and you know we have to do a little bit more maintenance. I'm kind of expecting we're going to have to get a maintenance crew on board from time to time to help keep up with some of the maintenance on this additional equipment.
And just one last thing, if when this COVID and everything gets over, I mean, to me, this is a kid in the candy store. I would love to take a tour. It's just impressive, the numbers there and stuff. So thanks, and great presentation, and looking
thank
forward
you, Robert.
to seeing it someday.
Yeah, well, please reach out to us. Yeah, there's definitely challenges with getting people on and off our ships today with COVID, but yeah, when this gets by, if you still have an interest, please reach out to us. Thank you.
Looks like John Kennish has a question.
Yeah, I was kind of curious about the qualifications of the operators here, because you're really talking about a chemical processing plant. Are these people going to be certified to meet the standards that the Coast Guard wants, or is it going to be controlled strictly by ConocoPhillips, or who's involved in all that? And who is going to make decisions about removing the equipment and replacing it? What kind of a time frame are you in terms of long-term use repair for this equipment? Thank you.
Yeah, I guess, you know, there are a lot of different systems out there. You know, again, as we approach everything, safety is a big part for us. You know, we wanted to make sure that the equipment, the chemicals that we have on board are safe and don't require an awful lot of things above and beyond. And that was part of our drivers in our decision process here for this. So yeah, there's really no chemical requirements for our crew. The product on board is safe. And the system itself is designed, as you know, Erica was saying, it monitors things automatically. I mean, we do some testing of our tanks periodically. We'll take a sample to, you know, depending on our voyage length, the level of chlorine in the tanks is important to us. So we do some testing of the tanks, but it's pretty simple. We have, you know, some hot testers on board that make that pretty simple to do. But yeah, it's the crew's a big part of operating it. Yeah, we certainly wouldn't ask them to do anything above their qualifications or experience.
And I intended to mention it before, but just to put it in perspective, I guess, on the concentrations of the chlorine, maybe it sounds more than it is, but the concentration of the chlorine in the tanks is well, when we did that testing last week, when we did the production test and actually measured the amount of chlorine, I asked them also to measure the amount of chlorine in the local water system down there in Sugar Land, just south of Houston. And the potable water had 8 parts per million chlorine. What we're talking about in our tanks is more like 6 parts per million. So we're within the limits of even, you know, what's allowable for humans to drink. And then on the other side, even the concentrate is still much less than, say, like the concentration of a gallon of chlorine. You know, that's a 6% by volume. And I think we're, please don't quote me, but I want to say that we're like at 1 to 1.5, something in that range.
Any further questions? I have a question, fellas, about the filtration system and the scrubbing system. When it goes into that automatic cleaning mode, does it valve so that water that is scrubbing out that sediment and stuff just go back into the environment that it is pulling the ballast water from?
Yes, that's right. It's called the back flush cycle there. It's all water, and you know, part of the approval process there is it's just that we're taking it on right there. So we're kind of a separate system that you see that from the filters, when they clean it out, it goes right back to where we're taking the water from. So
got it. And I would totally imagine that there is a strict requirement for testing your automation and sensors for the Coast Guard. So I know that when they come and inspect things, they make you go through the whole thing and qualify all that system. So
they do, and you know, to avoid that, you know, we take the additional steps. You know, again, there was a cost for doing that, but you know, versus just having everything show up in Singapore, we put it all together. All the equipment here in Texas with the Denora company here and the experts, and run through all the parameters there, all the trips, all the readings, make sure everything's right. And I think you saw in that one picture, there's, you know, 6 or 7 different controllers. So we have one of these on the bridge, we have one on our cargo control room, we have one down below in the engine room, and all of them have to work and get the right signals and all that. And we try to do all that in advance because yes, we do have to go through a bunch of thorough testing before we're able to say the system is commissioned.
Thanks for that. And I can certainly appreciate the hard effort in retrofitting a system like that in a ship. It is not easy. So thank you so much. It was a great presentation, and we really appreciate it.
Yes, well, again, thanks for the opportunity. Really appreciate it. Yeah, I'm sorry, I'm not a Zoom guy. My camera wasn't able to work, but I'm glad the audio did on my side. But yes, thank you again for the opportunity. We really appreciate it.
You bet.
Yeah, thank you very much.
Have a great day.